not sure why I picked this specific unit to showcase, because it seems like since the time I got it up until now, it just completely leaked out, and now it doesn't want to work. So what we'll do in this case, maybe we can actually try to get access to the data by alternative means. Okay, so what we'll do in this case, let's try to power it up through the utility. I'm going to shut it down. We got these two holes right here. I'll show you them in the microscope. These ones right here. If we short them out and power on the device, when we go into the PC3000, it comes ready right away. But if we ID the unit, it will change the ID information into a generic standard SM2258 controller information. At this point, we need to enter a vendor specific utility, not a universal utility. So what we can do here is go by the controller type, Silicon Motion, enter 58 XT. Start it up and see what sort of options we've got. So detects it has got the Toshiba chips on there. It's attempting to pull up a loader that's in the database. Now that the firmware version, internal firmware version, has been detected, and that is the code right here, it gives us suggestions for step 2 of the loader. So we're going to pick this guy here. And now it will want same shorting. So here we go, we've got the tweezers out. Hit next. And now we'll just wait until it runs same thing with the appropriate loader. At this point we can release the tweezers because it's already doing the work that it needs to do. This process can take a while, so I'm not sure how long we're gonna wait, but when it's ready, I'm gonna try and see if the data is accessible through this, and how well it reads if it is accessible. And we're gonna try to do, if this gets done quickly enough, what we're gonna try and do is take the memory off of here, swap it onto here, and attempt to load the same loader only on this board instead. And that way we're going to see whether or not technological mode has any preferences to how physically the PCB is set up or not. Alright, looks like it finally finished building the translator, and now it's the fun part. Let's see if this actually will give us access to the data and how well the data is gonna be able to be read. We're gonna create a test task again. This time we're not selecting disk 1. We see P3 1 terabyte. That's exactly the name we were getting this device to come up with when quickly requested the ID. So I'm going to choose that, make a copy into virtual disk. The size is already known through the utility, and we're ready to test this out. There is the map, and looks like we are able to read data, and it's detecting partitions. It's got 2 partitions here. And sectors do reread. You see these black dots here? If we try to reread it multiple times, we may get lucky. With the first sector we were able to obtain it, so now if I go to refresh, it should give us some more info. Okay, let's go this way. Let's build a map of all of the bad sectors. Try to read them as a multipass. So I read 2 out of 3 in a 100 pass attempt. And it was able to read them all. At least I thought so. Let's go again. There we go. With a little bit of heat, we were able to read this out. So now we got all those bad sectors obtained. So our partition let's see if we can get access to the MFT map and see how well that's gonna read. So this is a bigger chunk of data. We need to read 220 megabytes. So setting it up. This is what it reads like without any heat. While it's doing that, I'm gonna start raising the heat on the chip slightly. And as you can see, when it's warming up, it's starting to produce less of these bad sectors. So adjusting the temperature with controllable heater, we can maybe find that optimal temperature range where the device is performing the best under. But basically in this quick episode, you guys see what sort of things can be done when it comes down to PC3000 utility for silicone motion. As you can see, the temperature is dropping now. So if we start heating it up again, it should start showing improvement again. Using this technique, if we can get clean enough preview of the MFT, it shouldn't be too difficult to get access to the data. But the only thing with working these types of cases, as you may imagine, is the speed and estimated time of how long that's going to take, because we're dealing with only small portion of information here. We're trying to extract 220 megabytes, and so far we only gone through 40 megabytes. Okay, so this is approximately going to take about 9 more minutes to finish at the current running speed, and we're getting somewhat average of let's say 1 megabyte when it's heated. So yeah, it speeds up to 1.8 as the fastest I've seen so far. But that's a really good speed still, even if we need to image the entire used space, because with that kind of speed we might just be looking at a couple of days of work. I've had cases where speed is measured in bytes, not even kilobytes, but just literally bytes, like 15 bytes a second, and constantly dropping power off and on, and not hard to imagine how long these cases may require. So we're actually approaching a 40% mark, and I'll let this run actually because this is a case that needs to be solved still, and it looks like for the next few days the work is cut out for it. Thanks guys for tuning in for this episode, and I'll see you guys in the next one.